Okay, so second part here, we'll just go through the explanation of charging by contact and induction here. What's actually happening physically with the charges. Uh, so we'll do that here in our notes a little bit. And then maybe on day 3, we'll look at just doing some tests with electrostatics materials as well. So we'll wait for our blackboard to pop open, and basically we'll look at what is a conductor, what is an insulator, how they differ, and then we'll look at charging by contact and then charging by induction if we have time for that. Of course, we did a 15-minute demo video, so I don't want to make this one too long here for today. Okay, so let's go ahead. This is day 2 in the electric fields unit, or fields unit actually. We're looking at electric fields to start with. Okay, so this is day 2. And what we're going to be looking at is we're going to be looking at insulators and conductors. And we're going to be looking at charging by contact and induction. And we might not get to the induction part. We'll see how far we get today. Okay, so the first thing we're going to do is we're going to just define what a conductor is. Okay, this is a material that allows electrons to flow and space evenly around it. Okay, that's what a conductor is. It allows the flow of electrons. An insulator, it basically inhibits the flow of electrons. Okay, and they do not flow evenly, or they do not space evenly around the insulator. Metals are conductors, insulators are like rubber and things like that. Air is actually a good insulator most times. Okay, so an example of that, if we draw a little picture here. So if we have a conductor, say just a round sphere we'll go with. So if we charge it from the left, charge it over here, it will have evenly spaced electrons all the way around it because they space themselves out. So we'll do some positive charges. We'll use plus for that. So positive charges don't move. So they'll always be spaced out like that. Negative charges, if we have a conductor, they'll be evenly spaced out. Okay, so we have do not move. And the electrons, the negative charges, the electrons are evenly spaced. Okay, so eventually they'll flow around and everything will kind of balance out and they'll be evenly spaced. Okay, an insulator is different. If you charged an insulator, okay, so if I put my charges in there, my positive charges are evenly spaced. Okay, now if I charge it on the left here with electrons, okay, they don't flow evenly, so that the charging electrons are focused in an area. Okay, so the conductor will allow the electrons to flow around till the electrostatic forces in between the positive and negatives are even. Here, because it's an insulator, it basically stays kind of where you put the charge. Okay, sometimes it'll flow depending on how much charge you have on it, but it takes a lot to make it flow in an insulator. Okay, so what we did then after that was we looked at charging by contact and then charging by induction. Now, I don't know if I'll have enough time to do both diagrams and explanations today because we did that 15-minute little video there, and you might want to, if you have your own electroscopes around and some balloons and stuff, you might want to try it yourself too. Okay. Sorry, guys. So I'm just going to do charging by contact and see how much time we have left. So let's say charging a conductor by contact. And the first thing is that when you charge something by contact, the conductor that you're contacting with the charging object is going to cause the same charge. So charging by contact, first of all, causes the insulator, sorry, not the insulator, the conductor, to become the same charge as the contacting object. Okay. So if it's negative, the negatives will flow onto the object. If it's positive, the negatives from the conductor will flow onto the other one. So there's two different ways that you can charge by contact as well. Okay, so the one that we're going to look at is charging and conductor with a positive object. That's what we'll look at first. Okay, so if we have a positive object, okay, so a positive object would be some kind of insulator, so we'll just say it's a rod. So let's just make it a point T rod. So if this is a positive object, it has more positives on it. Okay, so 1, 2, 3, 4, 5, 6, 7 positives, and then we'll put maybe 1 or 2 negatives in there. Okay, so there's our positive object. Okay, and then we have our neutral scope. So let's just draw the okay, these are not spread apart. Okay, so this is a neutral scope. That's E, I think. Oops. We'll call it a conductor. Okay, so if it's neutral, we have to have even amounts of negatives and positives. So let's put our positives don't move, so we'll put 2 there, 2 there, and 1 each there. Okay, so that's 6 on there, so we'll put 6 negatives, and they'll be relatively the same spot. So 1 there, 1 there, 1 there, 1 there, 1 there, and 1 there. So even number of charges. So that's the first step. Okay, so then we bring the object close to the scope, we'll call it. So we'll draw our
and I was like, it's this thing. And she was like, mm-hmm. And I was like, ah. So I don't know.
So if we bring this close, oh, get the right colors in here. If we bring this close to the neutral object, what happens is that the electrons in the neutral object, well, let's draw this a little better here. These are going to spread.
I was in first at halftime, and for like 5 questions, I was in first. And then I lost
Okay. Because what's going to happen is then the positives in the rod here are going to attract the negatives. So the negatives are going to come up close to that rod, and the positives in the oscilloscope are still going to be where they were. So we've got 6. We got 1, 2, 3, 4. We'll put maybe 1 there, 5 there, and maybe 1 there. So the rod that's positive attracts the electrons to the top of the scope, right? Okay, and then thus the leaves spread as the positives are left in there. Okay, and then we know that from electrostatic force, there's a force of repulsion. Okay, so that's what's happening when it comes close. So that we'll put 2 there. Okay, so whenever you bring something close, that's why before I touch it. So if I go ahead and touch it, what's going to happen is some of these electrons are going to flow off of the conductor. They're going to be attracted to these extra positives over here. So that's 3. Contact. So as contact has happened, okay, so we're going to draw this like this. Okay, we're still going to have these spread apart. So the positives don't move, so we can put the positives back here, no problem. Okay, now what's going to happen is that the extra positives that we had over here, which we had 7 of them, and a couple of electrons, are going to attract these electrons onto the bar. So put a few more electrons onto here. It's going to try and spread it out. So that only thing, there's maybe a couple left. So the electrons flow onto the rod. So some of them are removed from the electroscope or the conductor. So then now we have less electrons than we began with. We began with a neutral object of 6. So now we're going to only have 2 left over. So when we remove the rod in 4, okay, the rod has a few extra electrons on it. The oscilloscope, or not the oscilloscope, the electroscope is still charged, and it's charged positively because it has 1, 2, 3, 4, 5, 6 of those charges, and only maybe 2 of these left. So now it's positively charged. Okay, so there's still that force. Might not be as much because the electrons might space themselves out a little bit, but there's still that electron, and that is charging by contact. Okay. Now the opposite is true. If this is a negative rod over here, in this step, everything would be the same. If you had a negative object, everything would be the same except for when you brought the negative object, the negatives would be repulsed down to the bottom. So if we had a negative object charging, it would look a little bit different. Okay. So this will be B. We'll do charging a conductor with a negative object. So you could probably figure this one out on your own. So kind of see if you can think it through, and we're doing it here together. So this one would be B, charging by contact with a negative object. Okay, so our first step would simply be this. Okay, obviously we'd have the same kind of idea, a negative object here. So we'd have, let's give it 5 negatives and 1 positive. And let's give ourselves a neutral object here. So let's give them 6 each like we did last time. 1, 2, 3, 4, 5, 6, and then evenly with the negatives. 1, 2, 3, 4, 5, 6. Okay, if we bring this close, if we bring it close, the negatives are going to repulse the negatives in here and push them down. So we're going to have some force in there. But the negatives that were here, we're going to have the 3 negatives are going to get pushed down to the bottom. The positives don't move. So we'll still have 1 there, 1 there, 1 there, 1 there, 1 there, 1 there. So the rod oops, not that. There we go. Rod repulses the negatives to the bottom. Okay, so now if I bring this in contact, these are going to flow onto the scope because there's extra positives here that they're going to be attracted to. Okay, these are repulsed away. So contact happens. Okay, and what we're going to do is there's still repulsion here. We got those three there, down there. But what is happening now is that these electrons are going to start flowing onto here to try and repulse it. So let's say 3 electrons flow onto there. So the electrons flow on the scope. Okay, and that's 3 and 4 at the end. Then when it's all evened out, we're going to have an extra 3 electrons. So we're going to have, so instead of 6, we got 5, 6, 7, 8, 9 like that, and 6 of these. 1, 2, 3, 4, 5, 6. So this has become negatively charged, which is the same as the rod. Okay, so there's the 2 different states of how to charge something by contact. So just going through this last one, bring the negative thing, have a negative object with a neutral object, bring the negative object close, causes the negatives to push down away because there's repulsion. Okay, and then when you touch it, because they're all repulsed down here, these ones are attracted. Remember, negatives are the only charges that move. So these attract a few of the negatives onto the scope, and then when you take the rod away, okay, we should probably say take the rod away there, we then have extra negatives left on that neutral object to become now a negatively charged object. Okay, that's a good 20-some minutes there, and with the 15-minute video that we did at the beginning of class, that's we won't probably have enough time to do induction, which we'll probably start next day. We'll look at the induction. One thing you might want to do is see if you can find yourself some electrostatic furs and balloons and things like that, if you have those types of things in your school, because we are going to do a little bit of an investigation with that in the next period or two as we go. Okay, so I'm going to stop the video there. That's charging by induction, or charging by contact. We looked at the demo. We'll look at charging by induction next day.